Mathematics Class 8th, Chapter 3rd, Exercise 3.4, Understanding Quadrilaterals. Here we are on question number 2nd. Identify all the quadrilaterals that have 4 sides of equal length and 4 right angles. There is nothing much in this question, we just have to represent. Rather, identify the quadrilaterals that have such conditions. Let's dive into the A part. 4 sides of equal length. We have studied that we have 2 quadrilaterals who have 4 sides of equal length, namely rhombus and square. If we consider rhombus, we have all consecutive line segments equal to each other, whereas in case of kites, only consecutive line segments are equal. That thing only differentiates rhombus with kites. And another figure is square, where all the 4 sides are equal to each other, and a rectangle is a figure where all 4 sides need not to be equal in measure. With this, rhombus and square are those quadrilaterals who have 4 sides of equal length. That solves our A part. B part, 4 right angles. We have 2 figures that follows this condition, that is square and a rectangle. In square we have 4 internal angles equal to 90 degrees. That is, all 4 angles are right angles, whereas in case of rectangle, the same property holds true. That is, measure of each angle within this rectangle is equal to 90 degrees. So this was a very simple question, where this question number 2nd has been solved. Question number 3rd, explain how a square is a quadrilateral, a parallelogram, a rhombus, and a rectangle. In question number 1st, we told you that square is a figure that can be termed with another names like a quadrilateral, parallelogram, rhombus, rectangle, because square meets all the properties of these following figures. Now we have to show how we can name square as following figures. So let's go for a quadrilateral. We have to explain how square is a quadrilateral. You know very well what is a quadrilateral. Any closed polygon which is entirely made up of line segments with 4 sides. So here we have one line segment, second line segment, third line segment, fourth line segment, and it is a closed curve. That is, where initial starting point is also the terminating end point. So the reason being, a square is a 4-sided, so it is a quadrilateral. That is first part. Now we have to explain how a square is a parallelogram. So what are the conditions for a parallelogram? That is, opposite line segments should be equal and parallel to each other. So square meets this condition. As you can see, opposite line segments are equal and parallel to each other. Again, opposite angles should be equal to each other. So here 90 degree, and the last condition is alternate angles. The angles formed on the endpoints of a line segment, their sum should be supplementary. That is, addition of these 2 angles. So these are the conditions of a parallelogram. And square meets all of these conditions. So the reason being, a square has its opposite sides parallel, so it is a parallelogram. And other properties you can also write that we just discussed. Therefore, this defines how square is a parallelogram. Talking about rhombus, that how square is a rhombus. So what are the conditions for the rhombus? So these are the condition of rhombus. That is, diagonals should bisect each other. Also, they are perpendicular bisectors. So what is the difference between bisection and perpendicular bisection? In bisection, a line segment is divided into 2 equal halves. When we say perpendicular bisector, then the line segment crosses each other at 90 degree. That is, there is a formation of 4 angles. First angle is this one, second, third, fourth. That is, all 4 angles will be 90 degrees. When this happens, then we say perpendicular bisection. So rhombus has this property of perpendicular bisection. Also, all the 4 line segments are equal to each other. The same condition is followed by square. Therefore, we can say a square is a rhombus, and the reason being, the diagonals of a rhombus are perpendicular bisectors of one another. Same is the case with squares. As you can see, these diagonals are of equal length. Also, all 4 line segments are equal, and diagonals divide each other perpendicularly. That is, this angle is 90 degrees, 90 degrees, 90 degrees, and the last one is 90 degrees as well. So with this, we have defined that how square is a rhombus. Last part, we have to explain how square is a rectangle. What are the conditions of rectangle? So we have written it down. The diagonals of a rectangle are of equal length. If you observe in rectangle, the diagonals are of equal length. Similar is the case with square. The diagonals are of equal length in measure. It says also bisect each other. The same we discussed here. That is, this line segment length will be equal to this line segment length. That is, diagonals divide each other equally. That is in two halves. Further, each angle is a right angle. Also, in case of a rectangle and square, each internal angle is equal to 90 degrees. So this is the reason that how square is a rectangle. With this, fourth part is also solved. And this completes our question number 3rd. Question number 4th. Name the quadrilaterals whose diagonals, number first, bisect each other. And second is, are perpendicular bisectors of each other. And the third is, are equal. So we have to name the figures which follows these conditions. So let's focus on first part. We have to name the quadrilaterals whose diagonals bisect each other. So we just discussed that parallelograms bisect each other, rhombus bisect each other, square bisect each other, and rectangle bisect each other. So if you observe for the parallelogram, we are considering an example where this line segment is bisected in two equal halves of measure 51.21 centimeter. Same is the case here. Important point to note is that measure of both diagonals is not necessarily equal in case of parallelograms. But this is not asked in the question. We just have to tell bisect each other. So when we say bisect each other, how this actually happens? If we draw this diagonal, so a diagonal cannot bisect itself. We need another diagonal. Therefore, in case of a quadrilateral, you know very well, there are 4 sides. So 2 diagonals can be drawn that connects 2 opposite vertices. That is the basic definition of diagonals. So another diagonal will bisect the initial diagonal. That is, they bisect each other. That is how bisection happens. So this measure is different, but it has to follow this property of bisection. That is, measure of this particular line segment that has been bisected will be equal to this one. Therefore, 37.24 centimeter and 37.24 centimeter in our example. That is, this diagonal has been bisected by this diagonal in these 2 measurements of equal measure. Similarly, this diagonal is bisected by this diagonal in 2 equal halves of this measurement. So this is how bisection happens. Now in case of rhombus, again, diagonals are bisected. That is, measurement of this line segment will be equal to this line segment, and this line segment will be equal to this line segment. Again, for square, diagonals are bisected, that is divided in equal halves by another diagonal. And in case of rectangle also, we have diagonals of equal measure, but when they are bisected by each other, then they form 2 equal halves. Therefore, first part has been solved. Moving on to second part, it says we have to name quadrilaterals whose diagonals are perpendicular bisectors of each other. We just defined what is perpendicular bisection. That is, dividing line segments or diagonals in this case into 2 equal halves with the condition that they bisect at 90 degrees. That is, 4 90 degrees are formed. So we just discussed in previous question that rhombus, so this denotes rhombus, and square are those figures which have perpendicular bisection because each angle inside is formed which is equal to 90 degrees in case of square and in case of rhombus as well. With this, second part has been solved. Moving on to third part, it says we have to name the quadrilaterals whose diagonals are equal. We just told you here and here. So the same figure has been represented over here. This is square and this is rectangle. In our example, each diagonal measure 30.17 centimeter. Again, 30.17 centimeter in case of a square. So it follows the condition that diagonals are equal. Again, we took an example of rectangle whose diagonals measure 35.82 centimeter, this one, and this diagonal also 35.82 centimeter. So with this, third part is also solved. So you see how easy it is to solve when you know exactly the properties of two-dimensional figure that we have studied in chapter name Understanding Quadrilaterals. With this, our fourth question has been solved. Question number 5. Explain why a rectangle is a convex quadrilateral. We have learned in the previous exercises that what we mean by a convex polygon. Let's revisit the concept of convex polygon. So a polygon is a geometrical figure that is two-dimensional, which is entirely made up of line segments, where initial point is also the last point. That is, it is a closed polygon. So quadrilateral is one of the form of a polygon with a specification that number of line segments should be 4. Similarly, the question could ask convex pentagon, convex hexagon. This time it particularly asked that why a rectangle is a convex quadrilateral. With this idea, let's try to explain. So the solution goes like this. A convex quadrilateral is a 4-sided polygon that has interior angles that measures less than 180 degrees. Same we studied in case of convex polygon. So here we have represented a rectangle. Here, if you observe, all the internal angles is 90 degrees. That is less than 180 degrees. Also, the diagonals are contained entirely inside these quadrilaterals. This is another definition that follows convex quadrilateral. So we have two diagonals in case of rectangle. So the diagonals always lies inside the boundary of this rectangle. All these positions is the inside of this rectangle, and this is outside boundary of this rectangle. So the diagonals is always contained entirely inside of these quadrilaterals. Therefore, these two conditions, that is, each individual angle inside the rectangle is less than 180 degrees, that is 90 degrees in case of rectangle. Also, the diagonals that can be drawn within this rectangle are contained entirely inside this rectangle. So with this reason, we have explained why a rectangle is a convex quadrilateral. That completes our question number 5. Last question of this exercise is question number 6. So it says ABC is a right-angled triangle. So let's go to the figure part. ABC is a right-angled triangle. It simply means whatever is written in between these vertices will have right angle that we have learned from the previous standard. Therefore, this triangle have 90 degrees at vertex B. The same has been represented over here for a better understanding. So we are given with a triangle ABC having 90 degrees at vertex B. Now, O is the midpoint of the side opposite to the right angle. So side opposite to this right angle is this one, or the hypotenuse in this case, and O is the center point of this line segment AC. Now we have to explain why O is equidistant from ABC. We have to tell that this point O is equidistant, that means of equal measure from A, B and C respectively. That is, the distance of AO, BO and CO will be equal to each other. This particular statement needs explanation, and the hint is given to us. The dotted lines are drawn additionally to help you. That is, these are dotted lines. They are just given as a hint. So based upon our understanding of this concept of parallelograms and quadrilaterals, we shall try to answer why this O point is equidistant from vertex A, B and C. So we go to the solution part. Dotted lines, that is this AD and DC, are parallel to BC and AB respectively. It simply means it is not provided to us that they are parallel to each other. We have to construct, and we have learned in previous standard that construction is from our own side. We need to construct sometimes in order to verify something. So we constructed the line segments that are shown in green color. That is line segment AD, which is equal to BC and also parallel to it. So this is our assumption. So do not confuse that why these are equal and parallel to each other. This has been done by us intentionally. Similarly, DC, that is this line segment that we have extended as a construction, is parallel to line segment AB, also equal to it. The same has been written in these two lines. That is, dotted lines AD and DC are parallel to BC and AB respectively. By respectively, we mean AD refers to BC and DC refers to AB. Again, AD refers to BC and DC refers to AB, where AD equals to BC and AB equals to DC. That is, AD equals to BC and DC equals to AB in measure. With this, we have constructed a figure named as a rectangle. And why we are sure that it is a rectangle? Because in rectangle, every angle is 90 degrees. Because these are parallel to each other, therefore measure of this angle should be equal to this angle that we have learned in case of parallelograms. Similarly, this side is equal to this side. So again, the angle formed over here will be equal to angle formed over here. Here we have completed 90 plus 90, 180. Remaining we have two equal angles that will have addition equals to 180. Therefore, measure of each individual angle will be 90 degrees. With this, we are sure that we have constructed a rectangle. So do not get confused why we are naming it as a rectangle. We have explained it very well. Now we write, in a rectangle, the diagonals, beside being equal in length, bisect each other. This we know from the property of rectangles that both the diagonals formed inside a rectangle are of equal measure, and also they bisect each other. Again, in statement part, we wrote all angles of rectangle are 90 degrees. We just explained it. And rectangle has two diagonals equal and bisect each other. That has been explained as well. Now, hence, AO equals to BO equals to CO equals to DO. Why we have written this thing? Since diagonals are equal and they are bisected, that means measure of each diagonals bisected will be equal to each other. Let's consider an example over here. In our case, measure of this complete diagonal is 80 centimeter. Since it is a rectangle, this will mean that this diagonal measure will also be equal to 80 centimeter. Again, they are bisected by each other. That means measure of this AO line segment, BO line segment, CO line segment, and similarly DO line segment will be equal to each other, and that will be 40 centimeter. Because 80 divided by 2 means 40 centimeter. With this, we have clearly shown that why this O point is equidistant from A, B and C, although it is equidistant from D point as well. But that was our construction, that was our imagination. We need not to tell it here. But for additional representation, we just wrote, hence, AO equals to BO equals to CO equals to DO. Therefore, it simply means O is equidistant from A, B, C and D. So this is how construction helps in order to verify something. It is our imagination and we can take any dimension of it. The only point is that our question should be verified. With this, we have completed last question, question number 6 of exercise 3.4, chapter 3rd, understanding quadrilaterals.